Alright, let's get down to some serious business here, namely LOL diagrams. So, what these basically are a way for us to organize thoughts about energy. So the whole idea about energy is that we have this weird quantity that we think is good for describing situations, but it's kind of hard to qualify necessarily. So we say things are moving if they have energy, and then things that can cause things to move have energy in some different way, or can transfer energy. So the easiest way to start with things is to think of one object. So consider, for example, this ball. This ball has been thrown. It's moving, so it has some kinetic energy. Before it was moving, it didn't have kinetic energy, so I might say it's something like this was going on. Let's say in the initial state, not the before state. So the ball is in hand. And we're going to say that there is no energy, basically, for the ball. And then the final state, the ball is in flight. And because the ball is moving, we're going to say that it has some kinetic energy, maybe 3 bars. So, in this case, the way we're looking at it, the object under consideration is the ball, and I'm going to make the ball all alone in my system. So the only energy that I have to consider here is kinetic. That is all that we can have if we just have one little thing all by itself. So, slight problem here though. We think that the first law of thermodynamics should go something like this, that the initial energy plus the work is equal to the final energy. But right now, there's no initial energy, and there's 3 final energy. So that means that there has to be some work. So, what's interacting with the ball? Well, in the simplest case, and I urge you to consider the simplest case, there's no reason to make your life more complicated than it needs to be. We have the thrower, or the person, we'll just say. Now, the person is not in my system. So if the person interacts with the ball, the person is going to do work on the ball. In this case, the person is evidently going to put in 3 bars of energy. And again, the idea with this O is that this O represents the system. So if energy goes into my system like this, I'm doing positive work. If energy comes out, negative work. So, that seems reasonable. Let's try it again. Still have a person. Still have a ball. Ball is still in flight. So, initial, work, final. A lot of these times, these things are going to look like puzzles. So we'll know some information and kind of have to piece it together. So we said that this wound up with 3 bars of kinetic before, so that's fine. So we have the ball, we have the person. This time, let's put the person into the system. So now, I'm looking at something like this. So now we have an interesting question. If there is nothing in the outside, then there is nothing to do work. If there is no work, then that means there has to be some extra energy in my initial state. There has to be 3 bars of it somewhere. So who has it? Well, the only other thing in my system is the person. So what kind of energy does a person have? Well, there's some rest mass energy, there's probably some kinetic energy, but the one that we're going to be interested in probably, energetically speaking, we're going to say there's some chemical energy. So, you know, related to fuel or organic stuff. Fuel is not spelt that way. It's kind of a catch-all, but we'll go with it. Let's consider another case. So we have this ball, right? And it's flying through the air. taking kind of this parabolic-y path, going something like this. So, if these are my three states, then I can ask kind of what's happening to the energy. This is a lot like the skate park question. So I might make an LOL OL if it's, really engaging. And so if we look, we know that the ball is going to slow down as it goes up. So if I threw it straight up, it would be basically stopped at the top. But since it's always going sideways, there's only going to be a little bit of speed. So I've got some kinetic here, because it's moving. I know it slows down a little, so I've got less kinetic. And likewise, as it falls, I know it's going to speed up again. So, if I take the system just to be the ball, what is the ball interacting with? Well, what is slowing it down and speeding it up? The answer is the Earth. And this is the interaction that basically we're going to think of as gravity. So, one way to look at this, in this case here, is to say that here, one bar goes out to the Earth. And here, one bar comes in from the Earth. And that's kind of the simplest way to look at it. Alternatively, I could think of both of these in my system. And now that they are both in my system, I can think of this kind of collective thing as being some gravitational energy, because both of them are here. All of these potentials are always going to be relating to things. So now, instead of there being work to and from the Earth, I have a block of gravitational energy stored here in this relationship. Both are valid. They're just two different ways to look at it. There are going to be thus many possible right answers for these, and we're just going to have to get, used to that a bit. So this is just a taste of it. We can also have energy stored in springs, and if we're going to do that, that is elastic energy. And those are the kind of the big ones that we're going to worry about. Springs, height, sort of fuel, living things, we'll think of as chemical, and movement will be our kinetic. There are many other options, but these are the ones that we're going to start with for now. So, hopefully this helps you doing the homework. Good luck.